welcome to Arduino tutorial number 5, hosted by the real Tony Stark, who apparently sounds like Ray Romano. In this tutorial, we will be covering topics such as variable types and basic breadboarding of an LED. For the tutorial, you will need the Arduino software, preferably an Arduino Uno and USB cable. Also, a breadboard with any color LEDs and accompanying jumper wires, and some sort of giant muffin or baked good that can hold a sword. Okay, so what are we talking about here? Well, today we're talking about variables. What are we talking about when I say these words? Well, if you go to the Arduino.cc website and you go to reference, you will see again these list of variables. Now, in previous tutorials, I have covered high-low, input-output, not true-false, and definitely not data types. So that's what I'm really going to be covering in this tutorial. Now, will I be getting into detail in all of them? No. More so, I'm going to be covering the ones that I use on a very regular basis. There are many tutorials out there that will cover the rest, but I'm going to cover the ones that I use for all of my purposes. Now, before we get going any further, if you want to follow along with exactly what I'm doing and you have access to a breadboard and some LEDs, this is the basic setup that I am using. Now, one thing you may notice, and it's just good practice, okay? First of all, if you've never used an LED before, LEDs, light emitting diodes, okay, they all have the same format if they're in the 5mm or even 3mm size. Now, these came with the SparkFun Inventor's Kit. This is a basic red. And you will notice that the legs, there is a longer leg and a shorter leg. The longer leg is the positive. The shorter leg is the negative. Now what that means is, it's important in which way you connect these to your Arduino. The word diode means that the current only flows in one direction. So, when I plug it into my breadboard here, I am putting that short end into the same long row as the, in this case I've got the blue one, that's my ground. Okay, so negative, ground, for our purposes are the same thing. And so I've got that short leg in line here for both of the LEDs. Okay, this is the short leg of the yellow, is in there. The long leg positive side is going into any one of these rows, doesn't really matter. And then it leads over to a resistor. Now, there's a whole thing that you can go into in terms of choosing the right resistor. If you get the Arduino kit, they come standard with 330 ohm resistors. Okay, I would totally say that just go with those in all your purposes for breadboarding right now. All that means is it's a lot higher than you need for these LEDs, but it's going to limit the amount of current coming from the Arduino and prevent you from burning out your LEDs. So they're not going to be as bright as they possibly could, but they will illuminate enough for us to do some testing. So that is basically it. Now, in terms of connecting the other side of the resistor, notice that I've got them bridged across that middle gap, because if you've seen the other tutorial, you'll know that these rows are not connected. These ones are, and these ones are, but not across the middle. So I've got the resistor going across, and then I've got a red wire to pair up with my red LED, and a yellow wire to pair up with my yellow LED. Also, down at the end of this blue row is a brown, which I'm just calling ground because I don't have a black wire, which we usually use to denote ground. I'm going to plug that into the ground on the Arduino. I'm going to plug my red into any of the digital pins over here. So again, if you watch previous tutorials, you'll know that digital is going to be best used for our outputs here. So I don't know, I'm going to choose 3 for this one, and the yellow, I'm going to choose 7. Wonderful. Doesn't really matter. That's just what I chose. Okay. So now we've got our breadboard set up. We can start working on our code. So, variables. Let's see here. We've got, what is the first one on the list? Void. Well, we've discussed void before. It's a very basic, it's the keyword for function declarations. So void setup, void loop, okay? There's not any information returned from these functions, but there has to be something to define them. And this again was covered in a previous tutorial. So that's void. Next one down, Boolean. Now, I didn't use these as often in the beginning, but I use them a lot more now. And basically what they are is they can hold one of two values. So it's a very small, memory-wise, this takes up very little space, okay, 1 byte of memory, and it's either true or it's false. There's only two possibilities that a Boolean can hold. So those are really good for determining states of a binary switch or something, or a condition where it's either this or it's this, and you can use a very little space in the memory of your Arduino. So we'll do some examples with Booleans. Char. Now these are short form for character. Okay. We're talking about strings or letters that we recognize. Now in Arduino Code, they're represented as numbers. So it talks about more detail. You can read through this on your own, but it talks about A is equivalent of 65. So you can actually do math with letters if you want to. I don't use char very often, mostly because I'm not outputting any words to any of my projects. But there's a lot more you can do with them than just that. But I don't use them as often in my project. So I'm going to skip these ones as well. By all means, go in and read up on them yourself. Int is the one I want to cover first for sure. Int is short for integers, and it's been a while since you've done math, an integer is a whole number, 1, 2, 3, -1, -2, -3, 0, okay, and so on. Now, one important point to note with integers, because there's a finite amount of space on your Arduino and on computers in general, an integer in this program, in this code, can only go up as high as 32,767 or -32,768 as the lowest value. That is simply because of the size of this variable or the data that it stores. So just be careful that if you're using this to count, realize that it can only count this high before you'll run out of room. Okay. So that's an important point to note for them. We'll go and declare those momentarily. What else we got here? Unsigned int, I'm not going to cover that. Neither am I going to do word. Long is like an integer, except it can go all the way up to 2 billion and change. And this is, as you can see, it uses 4 bytes of memory. So could you define all of your variables as long? Yes, but you're going to run out of space a lot quicker, and it's not really efficient use of the space if we do that. So we have to determine our variables based on their purpose. If you need something to count much, much higher than 32,000, this would be a better choice for that. What else? We've got float. Okay, again, any ones I'm not covering, feel free to go through and read on your own. Float is when you need decimal numbers. Okay, so it has a decimal point. You can define how many decimals you want there to be, but basically anything where you're doing not whole numbers, a float is going to be have to be used. And then string is just a group of characters. Okay, so words or text or something like that. And the last one that we'll get into later in the tutorial is array. And for just the simplest explanation of an array, what we're talking about is in one variable you can store multiple variables. So each of these can have a different value within this one definition here. So again, I'll come up with some examples of where I've used that before, but it's great for holding a group of numbers that are all in a similar class of information. So that's the main list of variables that we're going to cover today. So if we look at this is our previous code here in terms of washing or bathing a monkey. Okay, we're going to talk about that a bit again today. So at the very beginning, what I'm going to do is, as always, I always like to go and open up my bare minimum sketch, okay? Just for the sake of, we know that we need this code, so let's just put it in here right off the bat. Now, when you're defining a variable, okay, defining a variable, that comes before void setup and void loop. So at the very beginning, this is where your definition of your variables come. When you want to name it, you will notice that if we choose any of the types here, any of the ones listed as data types, they will come up as orange if you type them in correctly in the right case. So for example, if I type int, you'll notice it goes orange, and I can create an integer. If I type boolean, that also goes orange, and now I can create a boolean type. So the type always has to come first. What type of variable are you defining? And then we follow that with its name. So, what are we dealing with here first? Well, let's do boolean first, and let's look at our code. First thing that we're asking it to do is turn on the cold water faucet. So I know that the cold water faucet has two states. It's going to be either on or off. For these purposes, obviously you can have a real faucet be lower, but for my purposes, we're going to say it can only be on or it can only be off. So boolean would be a great choice for that because it's going to use the least amount of space, and we'll call this cold faucet. Okay, and then what you can also do here is define what its initial state will be. So booleans again can either be true or false. I'm going to say false. And the reason for that is I want to start the faucet being off. Okay, and then again at the end of your statement, we always have to include that semicolon. All right, and initialize cold faucet as off. All right, so that's our code, our comment again to make sure we know. Oh, right, that's what this code is doing. We're creating a boolean. We're going to start it off. Great. Next line, boolean hot faucet. And again, notice the way that I'm typing my variables. If it's more than one word, we start the first word as lowercase, and then every subsequent word we start with an uppercase letter. Just good practice so you can identify, and it's easier to read when it's all jumbled, because you can't have spaces in there. Okay, your variables must all be one word. Okay, and we're going to start that one as off as well. Initialize hot faucet as off. Okay, now the next part of our pseudocode here says keep on for 2 minutes. Well, right there, that 2 minutes, we're going to need something to keep track of that time. So I can't do a boolean because it's got to have multiple values. It's going to go from 0 up to 120 seconds. So in that case, that falls within the range of an integer. So I could say int, and I will call this faucet timer. Okay, and we'll say equals 0. Great. So that's going to initialize our timer. Initialize timer at 0. Okay. Again, this is just good practice, and all we're saying here is we've covered 3 variables now. We've got cold faucet, hot faucet, and faucet timer. Now, do we need a separate faucet timer for each of these? Possibly, but we'll know that when we get further into our code. Okay. Now, for the demonstration of this code, what I'm going to do is I'm going to use my red LED as the hot faucet, my yellow LED as the cold faucet, and we'll just activate those as needed. Okay, so we need some more definitions here. Now, because all the pins on there are numbers, whole numbers, we usually define the pins as integers. However, the pins, unlike the timer is going to be a changing variable. All right, so it varies, and because of that, we just define it as an int, which means that it can be changed. It will always be a whole number, but it can be changed. It starts at 0, but throughout the code it could change to anything else. However, when we define our pins, it's very good practice to not only define it as an int, but to precede that with const. All right, that stands for constant. Okay, and what that means is this variable will not be able to be changed. So that just limits the variable. It doesn't. It's not a huge deal. I mean, you could just define it as an int. I find it very good practice to, if you know the variable is going to stay as something throughout your entire code, for example, it's always going to be pin 3 for this hot faucet LED. Okay, then it's a good practice again to make it constant. All right, we don't want that variable to be changed at all. Red LED is pin 3. Const int cold faucet LED equals 7. Yellow LED is pin 7. All right. So now we've got our variables. Now what can we do with them? Well, again, in the void setup here, this is where we have to tell our pins now, what are they, right? They don't know what they're supposed to be doing. So we're going to say pin mode, and we've got hot faucet LED, comma, output. And then don't forget our semicolon. Pin mode, cold faucet LED, output. And you know how we said that we want this to be off first? Okay, well, this is a Boolean and a variable that we'll be using to track that throughout. But when you initialize these LEDs, they may not be initialized at the state we want. They'll know their output, but they won't know if they're supposed to be on or off. So in void setup, again, if we know what we want them to do right off the bat, we're going to set that using digital write. Okay, now again, this is because we're using the digital pins, and we want just an on or an off. Okay, digital write, hot faucet LED, low. And that's just going to start the LEDs off, cold faucet LED low. Start them in the off position. Okay, so we've initialized our LEDs, our pins that we're using for this. Okay, we don't have to initialize the ground pin, that's always a ground. Now we go down here. Okay, so first thing we want to do, yeah, it says we want to turn on cold water, turn on hot water, leave on for 2 minutes. That's great. Okay. However, we want to make sure that we've wired our LEDs up first. So let's do a very basic test just to see if I've connected it properly, if I got it to the right pins, if any of my code is right here so far. So let's check that first. So the first thing, all I'm going to do is say digital write, hot faucet LED high. And then I will say delay 1000, digital write, hot faucet LED low, delay 1000 milliseconds. Alright, so all we're doing is doing the blink code essentially, and I just want to see if my hot faucet, my red LED flashes when I upload this code. So again, I've got my Arduino Uno selected here on COM3. So when I upload, oh, look at this, compiling sketch, no errors in my code, and hey, we have a blinking red LED. Wonderful. So let's try it with the yellow. Let's see if the yellow works. So all I'm going to do is I'm going to go back in my code here. I'm going to change that hot to cold. Because I named my variables very similarly, that's all I have to do now to test the yellow LED. And I'll re-upload. And there's yellow. Perfect. So now we know that we've assigned our variables properly, we've connected our circuits properly, so now we can start working on, let's get some of the pseudocode happening the way we want it to. So, first thing we want to know at the very beginning is, well, I guess we want to turn on these faucets. So, digital write, hot faucet LED, high, okay, and digital write, cold faucet LED, high, delay. Now, I'm not going to say 2 minutes because I'm not going to sit here and make you sit here for 2 minutes to see if that works. So I'm going to say 2,000 milliseconds or 2 seconds. All right. So this is turn on hot water. Turn on cold water. Wait for 2 seconds. In this case, I'm not going to do 2 minutes. Okay, so that's fine. But then it says turn off both faucets. So now, instead of me typing out this whole thing, we know that this code is going to be virtually the same. So save yourself some time. Once you have something that is virtually identical, I've copy and pasted that. Instead of them being high now, we're just going to change them to low. And this is off. Make sure you update your comments when you do that. Okay, and touch water with fingers. Okay, so we're not going to do that part yet. We just want to see, does this turn it on for 2 seconds and then off? Okay, now don't forget here, let's go through our code and see what happens. It says turn them on, wait 2 seconds, turn them off. How long is it turning them off for? Well, in this case, we haven't defined that. So it's going to blink it's going to right back after this and turn them on again. So we're not even going to see them turn off if we do that. And I can upload that to show you. We'll see both of them come on and stay on according to my logic here. And of course, that is correct. So what we want to do then is, how long do they have to stay off for, right? Well, according to our pseudocode, we have to test the water, the temperature, to see what the state is, okay? Now, up here, we've defined these booleans. We haven't used these yet, cold faucet, hot faucet, and we may not have to. It was more of an example, and we may get to a point where we don't need that. Now, we also have our faucet timer, okay? So how do we use that? All right, so this is again, we said for 2 minutes. So instead of saying 2,000 in here, I could go faucet timer. I could put that in there, and I could actually start this at 2,000. So that now is going to always be set at 2,000. So I can then change it later when I'm going to do 2 minutes. I can just change it here, and it will change it throughout the code wherever we have that timer number in effect. So delay, I'm going to say same thing, and let's upload that. So now we're going to have essentially the blink code again, but we're going to see 2 seconds on, 2 seconds off, with both of them simultaneously. Okay, so that is the basic way that we initialize variables is up here. Okay, this is what we're really talking about. However, we haven't really accomplished what we want here because this is just a blink code essentially. We want to do something different. Okay, so how are we going to accomplish more of this? Well, there's going to be more done in future tutorials. The if statement is definitely going to have to be used. And so I think for today, we just wanted to cover some of these variables and just the format, things to think about when you fill them out. So I'm going to leave it at that for now. Play around with definition of variables, write some of your own code, see what else you can create in the interim. Next tutorial, we will be covering this assessment of the temperature of the water, and the booleans will come into play there, as will if statements and some other items as well. So If you have any questions or comments, please post them in the space below. Otherwise, until next time, this is the Real Tony Stark, signing off.